Weapon application of scalar longitudinal wave as directed energy weapons. The scalar beam weapons were originally invented in 1904 by Nikola Tesla, an American immigrant from Yugoslavia, 1856 or 1857-1943. Since he died in 1943, many nations have secretly developed his beam weapons, which now further refined are so powerful that just by satellite one can make a nuclear-like destruction, earthquake, hurricane, tidal wave, and instant freezing, killing every living thing instantly over many miles. It can also cause intense heat like a burning fireball over a wide area, induce hypnotic mind control over a whole population, or even read anyone on the planet's mind by remote. Due to the nature of behaving as a pressure wave and carrying tremendous energy, scalar longitudinal wave can remove something right out of its place in time and space faster than the speed of light, without any detectable warning by crossing two or more beams with each other. Moreover, any target can be aimed at even right through to the opposite side of the Earth. If either of the major scalar weapon-armed countries, for example, the United States or Russia, were to fire a nuclear missile to attack each other, this may possibly not even reach the target, because the missile could be destroyed with scalar technology before it even left its place or origin. The knowledge via radio waves that it was about to be fired could be eavesdropped and the target could be destroyed in the bunker, fired at from space by satellite. Above 60 Hz alternating current frequency, this wave can be very detrimental in nature. A scalar beam can be sent from a transmitter to the target, coupled with another sent from another transmitter, and as they cross an explosion can be made. This interference grid method could enable scalar beams to explode the missile before launch, as well as en route with knowing the right coordinates. If the target does manage to launch, what are known as Tesla globes or Tesla hemispheric shields can be sent to envelop a missile or aircraft. These are made of luminous plasma, which emanates physically from cross-scalar beams and can be created in any size, even over 100 miles across. Initially detected and tracked as it moves on the scalar interference grid, a continuous electromagnetic pulse Tesla plasma globe could kill the electronics of the target. More intensely hot Tesla fireball globes could vaporize the missile. Tesla globes could also activate a missile's nuclear warhead en route by creating a violent low-order nuclear explosion. Various parts of the flying debris can be subjected to smaller and more intense Tesla globes where the energy density to destroy is more powerful than the larger globe first encountered. This can be done in pulse mode with any remaining debris given maximum continuous heating to vaporize metals and materials. If anything still rains down on Russia or the United States, either could have already made a Tesla shield over the targeted area to block it from entering the airspace. Other useful aspect of scalar longitudinal waves in military application, there is a community in the United States that believes the scalar waves are realizable in its nature of mathematical approach. In recent conference sponsored by the Institute of Electrical and Electronics Engineers, these were openly discussed and a proceeding on the conference exists. The conference was dedicated to Nikola Tesla and his work. And the papers presented claimed that some of Tesla's work used scalar wave concepts. Thus, there is an implied Tesla connection in all of this. As it was stated above, these are unconventional waves that are not necessarily a contradiction to Maxwell's equations as some have suggested, but might represent an extension to Maxwell's understanding at the time. If realizable, the scalar longitudinal waves could represent a new form of wave propagation that could penetrate seawater, knowing the permeability, permittivity of salt water, and consequently skin depth, resulting in a new method of submarine communications and possibly a new form of technology for anti-submarine warfare. This technology also helps folks in naval special warfare communities such as Navy SEALs to be able to communicate with each other even in a murky water condition. Here are some mathematical notations and physics involved with this aspect of scalar longitudinal waves. The scalar wave, as it is understood, is not an electromagnetic wave. An electromagnetic wave has both electric fields and magnetic fields, and power flow in electromagnetic waves is by means of Poynting vector, as written below. Power flow equals electric field multiplied by magnetic field. It is measured in watts per square meter. The energy per second crossing a unit area whose normal is pointed in direction of energy flow is the energy in the electromagnetic wave. A scalar wave has no time-varying magnetic field. In some cases, it also has no electric field. Thus, it has no energy propagated in the electromagnetic wave form. It must be realized, however, that any vector could be added that may be integrated to zero over a closed surface, and Poynting theorem still applies. Thus, there is some ambiguity in even stating the relationship that is given by equation 6.38, and that is the total electromagnetic energy flow. 2. The scalar wave could be accompanied by a vector potential A, and yet electric and magnetic remain zero in the far field. From electromagnetic theory, we can write as follows. In this case, Fe is the scalar electric potential and A is the magnetic vector potential. The Maxwell's equations then predict the following mathematical relation as scalar potential waves and vector potential waves. A solution appears to exist for the special case of zero electric field and zero magnetic field, and zero magnetostatic scalar potential. For a new wave satisfying the following relations, magnetostatic scalar potential is proportional to divergence of scalar potential. Electrostatic scalar potential is -1 divided by the speed of light multiplied by change of scalar stress over time. Scalar stress field then satisfies the following relationship: divergence of scalar stress field squared -1 divided by the speed of light squared multiplied by change of scalar stress field over time squared. Note that quantity c is a representation of speed of light. Mathematically, S is a potential with a wave equation, one that suggests propagation of this wave even through electric and magnetic fields equals 0, and the Poynting theorem indicates no electromagnetic power flow. From bold point paragraph 2 above, there is a suggestion of a solution to Maxwell's equation involving a scalar wave with potential that can propagate without Poynting vector electromagnetic power flow. However, the question arises as to where the energy is drawn from to sustain such a flow of energy. Some suggesting a vector that integrates to zero over a closed surface might be added in the theory, as suggested in paragraph or bold point 1 above. Another is the possibility of drawing energy from the vacuum, assuming that net energy could be drawn from free space. Quantum electrodynamics allows random energy in free space, but conventional electromagnetic theory has not allowed this to date. Random energy in free space that is built of force fields that sum to zero is a possible approach. If so, these might be a source of energy to drive the S waves drawn from free space. A number of engineers/scientists in the community suggested, as stated in early statement within this write-up, that, if realizable, the scalar wave could represent a new form of wave propagation that could penetrate seawater or be used as a new approach for directed energy weapons. This author suggests considering another scenario where we may need to look at equations of more complete electromagnetic theory and new predictions of producing energy that way. Thus we generate scalar longitudinal wave, where the Lagrangian density equation for more complete electromagnetics can be defined as, where Lagrangian density equation is written in terms of the potentials magnetostatic and electrostatic as follows. The proof of equation was given in chapter 5 of this book. This is the area where there are a lot of speculations among scientists, around the community of electromagnetic and utilization of scalar wave as a weapon application, and you find a lot of good as well as nonsense approaches in the internet, by different folks. The present approach uses several approaches. 1. One is acoustic signals that travel slowly, 1500 meters per second in seawater. 2. A second is blue-green laser light that has a typical range of 270 meters, and is readily scattered by seawater particulates. 3. A third is high-frequency radio waves that are limited to a range of 7 to 10 meters in seawater at high frequencies. 4. A fourth is extremely low-frequency radio signals that are of long range, worldwide, but transmit only a few characters per second for one-way, bell ring calls to individual submarines. The new feature of this proposed work is the use of a novel electrodynamic wave that has no magnetic field, and thus is not so severely constrained by the high conductivity of seawater, as regular radio waves are. We have demonstrated the low loss property of this novel, scalar longitudinal, wave experimentally by sending a video signal through 2 mm of solid copper at 8 GHz. If one has a background in physics or electrical engineering, you know that unquestionably our knowledge of the properties and dynamics of electromagnetic systems is believed to be the most solid and firmly established in all classical physics. By its extension, the application of quantum electrodynamics, describing accurately the interaction of light and matter at the subatomic realms, has resulted in the most successful theoretical scientific theory to date, agreeing with corresponding experimental findings to astounding levels of precision. Accordingly, these developments have led to the belief among physicists that the theory of classical electrodynamics is complete and that it is essentially a closed subject. However, at least as far back to the era of Nikola Tesla, there have been continual rumblings of discontent stemming from occasional physical evidence from both laboratory experimental protocols and knowledge obtained from observation of natural phenomena such as the dynamics of atmospheric electricity to suggest that in extreme situations involving the production of high energies at specific frequencies, there might be some cracks exposed in the supposed impenetrable monolithic fortress of classical/quantum electrodynamics, implying possible key missing theoretical and physical elements. Unfortunately, some of these experimental phenomena have been difficult to replicate and produce on demand. Moreover, some have been shown to apparently violate some of the established principles underlying classical thermodynamics. On top of that, many of those courageous individuals promoting the study of this phenomenon have couched their understanding of the limited reliable experimental evidence available from these sources, in language unfamiliar to the legion of mainstream technical specialists in electrodynamics, preventing clear communication of these ideas. Also, the various sources that have sought to convey this information have at times delivered contradictory statements. It is therefore no wonder that for many decades, such exotic claims have been disregarded, ignored, and summarily discounted by mainstream physics. However, due to important developments over the past 2 years, there has been a welcome resurgence of research in this area, bringing back renewed interest towards the certification of the existence of these formerly rejected anomalous energy phenomena. Consequently, this renaissance of the serious enterprise in searching for specific weaknesses that currently plague a fuller understanding of electrodynamics has propelled the proponents of this research to more systematically outline in a clearer fashion the possible properties of these dynamics, how inclusion could change our current understanding of electricity and magnetic, as well as implications for potential, vast, practical ramifications to the disciplines of physics, engineering, and energy generation. It is the purpose of this book and particularly this chapter to report on these unique, various recent inventions and their possible modes of operation, but also to convince those listening of their value for hopefully directing a future program geared towards the rigorous clarification and certification of the specific role the electroscalar domain might play in shaping a future, consistent, classical, electrodynamics, also by extension to perhaps shed light on current thorny conceptual and mathematical inconsistencies that do exist in the present interpretation of relativistic quantum mechanics. In this regard, it is anticipated that by incorporating this more expansive electrodynamic model, the source of the extant problems with gauge invariance in quantum electrodynamics and the subsequent unavoidable divergences in energy charge might be identified and ameliorated. Not only does the electroscalar domain have the potential to address such lofty theoretical questions surrounding fundamental physics, but also another aim of this chapter is to show that the protocol necessary for generating these field effects may not be present only in exotic conditions involving large field strengths and specific frequencies involving expensive infrastructure such as the Large Hadron Collider, but as recent discoveries suggest may be present in the physical manipulation of ordinary everyday objects. We will also see that nature has been and may be engaged in the process of using scalar longitudinal waves in many ways as yet unsuspected and undetected by humanity. Some of these modalities of scalar wave generation we will investigate will include the following: chemical bond breaking, particularly as a precursor to seismic events, illuminating the study and development of earthquake early warning system, solar events, related to eclipses, and sunspot activity and how it impacts the Earth's magnetosphere. Moreover, this overview of the unique aspects of the electroscalar domain will suggest that many of the currently unexplained anomalies such as over-unity power observed in various energy devices, and exotic energy effects associated with low-energy nuclear reactions, may find some basis in fact. As we did mention at the beginning of this chapter, under Sec 6.0, in regards to the latter cold fusion type scenarios, the electroscalar wave might be the actual agent needed to reduce the nuclear Coulomb barrier, thus providing the long sought-after viable theoretical explanation of this phenomenon. Longitudinal electrodynamic forces in exploding wires, etc. may actually be due to the operation of electroscalar waves at the subatomic levels of nature. For instance, the extraordinary energies produced by Ken-Shoulders charge clusters may also possibly be due to electroscalar mechanisms. Moreover, these observations, spanning as they do cross many cross-disciplines of science, beg the question as to the possible universality of the SLW, that the concept of the longitudinal electroscalar wave, not present in current electrodynamics, may represent a general, key, overarching principle, leading to new paradigms in other science besides physics. This idea will also be explored in the talk, showing the possible connection of scalar longitudinal, also known as electroscalar, wave dynamics to biophysical systems. Admittedly, we're proposing quite an ambitious agenda in reaching for these goals, but I think you will see that recent innovations will have proven equal to the task of supporting this quest. Insight into the incompleteness of classical electrodynamics can begin with the Helmholtz theorem, which states that any sufficiently smooth three-dimensional vector field can be uniquely decomposed into two parts. By extension, a generalized theorem exists, certified through the recent scholarly work of physicist-mathematician Dale Woodside above as well, for unique decomposition of a sufficiently smooth Minkowski four-vector field, three spatial dimensions, plus time, into four irrotational and four solenoidal parts, together with the tangential and normal components on the bounding surface. With this background, the theoretical existence of the electroscalar wave can be attributed to failure to include certain terms in the standard, general, four-dimensional, electromagnetic, Lagrangian density that are related to the four irrotational parts of the vector field. Here is electrical permittivity not necessarily of the vacuum. Specifically, the electroscalar field becomes incorporated in the structure of electrodynamics, when we let equation 6.44 above for gamma equals 1, and k equals 6.28 multiplied by mass multiplied by the speed of light divided by Heisenberg constant. As we can see in this representation as it is written for equation 6.44, it is the presence of the third term that describes these new features. We can see more clearly how this term arises by writing the Lagrangian density in terms of the standard electromagnetic scalar and magnetic vector potential A, without the electroscalar representation included. This equation has zero divergence of the potentials, formerly called solenoidal, consistent with classical electromagnetics, as we see here. The second class of four vector fields has zero curl of the potentials, irrotational vector field, which will emerge once we add this scalar factor. Here we see that it is represented by the last term, which is usually zero in standard classical electromagnetics. The expression in the parentheses, when set equal to zero, describes what is known as the Lorentz condition, which makes the scalar potential and the vector potential in their usual form, mathematically dependent on each other. Accordingly, the usual electromagnetic theory then specifies that the potentials may be chosen arbitrarily, based on the specific, so-called, gauge that is chosen for this purpose. However, the more complete electrodynamic theory allows for a non-zero value for the scalar-valued expression, essentially making the potentials independent of each other, where this new scalar-valued component C in equation 6.45 that we may call it Lagrangian density is a dynamic function of space and time. It is from this new idea of independence of the potentials which the scalar value C is derived, and from which the unique properties and dynamics of the scalar longitudinal electrodynamics wave arise. To put all these in perspective, a more complete electrodynamic model may be derived from this last equation of the Lagrangian density. The Lagrangian expression is important in physics, since invariance of the Lagrangian under any transformation gives rise to a conserved quantity. Now, as is well known, conservation of charge current is a fundamental principle of physics and nature. Conventionally, in classical electrodynamics, charged matter creates an electric field. Motion of charged matter creates a magnetic field from an electrical current, which in turn influences the electric and magnetic fields. Before we continue further, let us write the following equations as: electric field equals negative divergence of electrostatic scalar potential minus change of magnetostatic scalar potential over time. That is relativistic covariance. Magnetic field equals divergence of magnetostatic scalar potential. That is classical's electric and magnetic fields in terms of usual classical potentials A and Fe. Change of electrostatic scalar potential over time divided by the speed of light plus divergence of magnetostatic scalar potential equals classical wave. Divergence of magnetic field minus change of electric field over time divided by the speed of light minus divergence of classical wave equals electric current multiplied by permeability of free space. Electric field and electrostatic field without the use of a gauge. Divergence of electric field plus change of classical wave over time equals charge divided by permittivity of medium. The more complete electrodynamics theory produces cancellation of change of C over time and divergence of C in the classical wave equation for electrostatic scalar potential and magnetostatic scalar potential, thus eliminating the need for a gauge condition. These effects can be modeled by Maxwell's equations. Now, exactly how and to what degree do these equations change when the new scalar-valued C field is incorporated? Those of you who are knowledgeable of Maxwellian theory will notice that the two homogeneous Maxwell's equations, representing Faraday's law and divergence of magnetic field, standard Gauss law equation for divergence-less magnetic field, are both unchanged from the classical model. Notice that the last three equations incorporate this new scalar component which is labeled C. This formation as defined by equation 6.48 creates a somewhat revised version of Maxwell's equations, with one new term, divergence of C in Gauss law, equation 6.50, where P is charge density, and one new term, change of C over time, in Ampere's law, where J is the current density. We see that these new equations lead to some important conditions. First, relativistic covariance is preserved. Second, unchanged are the classical fields electric and magnetic in terms of the usual classical potentials, magnetostatic and electrostatic. We have the same classical wave equations for magnetostatic, electrostatic, electric and magnetic fields without the use of a gauge condition and its attendant incompleteness, since the more complete electromagnetics theory shows cancellation of change of C over time and negative divergence of C. The classical wave equations for electrostatic scalar potential and magnetostatic scalar potential, and a scalar longitudinal wave is revealed, composed of the scalar and longitudinal electric fields. A wave equation for C is revealed by use of the time derivative of equation 6.50, added to divergence of equation 6.49. Now, as is known, matching conditions at the interface between two different media are required to solve Maxwell's equations. The divergence theorem on equation 6.51 below will yield interface matching in the normal component of divergence of C divided by permeability of medium as shown in equation 6.15. Squared changes of C over time divided by the speed of light squared minus squared divergence of C equals 4-dimensional divergence of C squared equals permeability of medium multiplied by change of charge over time plus divergence of current. Note, the above sets of equation 6.51 and 6.52 present wave equation for scalar factor C matching condition in normal component of divergence of C divided by permeability of medium, spherically symmetric wave solution for C and the operator 4-dimensional divergence squared equals squared change over time divided by the speed of light squared minus the divergence squared, and it is called Alembert operator. The subscripts in equation 6.15 denote divergence of C divided by permeability of medium in medium 1 or medium 2, respectively, and Ju is magnetic permeability, again not necessary that of the vacuum. In this regard, with the vector potential and scalar potential now stipulated as independent of each other, it is the surface charge density at the interface which produces a discontinuity in the gradient of the scalar potential, rather than the standard discontinuity in the normal component of electric field. Notice also from equation 6.51 that the source for the scalar factor C implies a violation of charge conservation, right-hand side non-zero, a situation which we noted cannot exist in macroscopic nature. Nevertheless, this will be compatible with standard Maxwell-Lien theory if this violation occurs at very short time scales, such as occur in subatomic interactions. Now, interestingly, with the stipulation of charge conservation on large time scales, giving 0 on right-hand side of equation 6.51, longitudinal wave-like solutions are produced with the lowest order form in a spherically symmetric geometry at a distance r. C exponentially depends on wave number, radius, frequency and time. Applying the boundary condition C approaches 0 as radius approaches infinity is thus trivially satisfied. The C wave therefore is a pressure wave, similar to that in acoustics and hydrodynamics. This is unique under the new more complete electrodynamics model since, although classical electrodynamics forbids a spherically symmetric transverse wave to exist, this constraint will be absent under more complete electrodynamics theory. Also, an unprecedented result is that these longitudinal waves will have energy but no momentum. But this is not unlike charged particle-antiparticle fluctuations, which also have energy but no net momentum. Now that we are here so far, the question of why this constraint prohibiting a spherically symmetric wave is lifted in more complete electrodynamics can be seen in the following sets of equation 6.54 as below for the wave equation for the vertical magnetic field. Changes of magnetic field over time squared divided by the speed of light squared minus divergence of magnetic field squared equals divergence of current multiplied by permeability of free space. Gradient-driven current is scalar longitudinal wave. The sets of equation 6.54 are established for wave equation for magnetic field resulting gradient-driven current in more complete electrodynamic for generating scalar longitudinal wave. Notice again that the source of the magnetic field is a non-zero value of divergence of current, which signifies solenoidal current density, as is the case in standard Maxwell-Lien theory. When magnetic field is zero, so is divergence of current. This is an important result. Then the current density is irrational, which implies that current equals divergence of k, here k is a scalar function of space and time. Thus, in contrast to closed current paths generated in ordinary Maxwell theory, which result in classical waves that arise from a solenoidal current density, for the scalar longitudinal wave is gradient-driven and may be uniquely detectable. We also see from this result that a zero value of the magnetic field is a necessary and sufficient condition for this gradient-driven current. Now, since in linearly conductive media the current density is directly proportional to the electric field intensity that produced it, where sigma is the conductivity, this gradient-driven current will then produce a longitudinal field. Based on so far calculations, we can establish wave equation for electric field solution for longitudinal electric field in more complete electrodynamics spherically symmetric wave solutions for electric field and current in linearly conductive media. Change of electric field over time squared divided by the speed of light squared minus divergence of electric field squared equals Alembert operator multiplied by electric field equals permeability multiplied by change of current over time minus divergence of charge divided by permittivity of medium. Electric field is exponentially dependent on wave number, radius, frequency and time. We can also see this from examining the standard vectorial wave equation for the electric field. The wave equation for electric field arises from the curl of Faraday's law, use of divergence of magnetic field from Ampere's law, and substitution of divergence of electric field from equation 6.50 with cancellation of the terms divergence of time varying C equals divergence of C multiplied by time gradient. When the right-hand side of equation 6.50 is 0, the lowest order outgoing spherical wave is electric field exponentially dependent on radius, wave number, time and frequency, where r represents the unit vector in the radial direction and r represents the radial distance. The electrical field is also longitudinal. Substitution of current equals conductivity multiplied by electric field into Alembert operator of electric field results in 0, meaning that current density is also radial. The scalar longitudinal wave equations for electric field and current are remarkable for several reasons. First, the vector scalar longitudinal wave equation for electric field and current are fully captured in one wave equation for the scalar function k. Alembert of k is 0. Second, these forms are like Alembert of c is 0. Third, these equations have 0 on the right-hand side for propagation in conductive media. This arises since magnetic field is equal to 0 for the scalar longitudinal wave, implying no back electromagnetic field from changing magnetic field over time in Faraday's law, which in turn gives no circulating eddy currents. Experimentation has shown that the scalar longitudinal wave is not subject to the skin effect in media with linear electric conductivity, and travels with minimum resistance in any conductive media. This last fact affords some insight into another related ongoing conundrum in condensed matter physics, the mystery surrounding high-temperature superconductivity. As we know, the physical problem of high-temperature superconductivity is one of the major unsolved problems in theoretical condensed matter physics, in part, because the materials are somewhat complex, multilayered crystals. Here the more complete electrodynamics theory may provide an explanation on the basis of gradient-driven current between or among the crystal layers. The new more complete electrodynamics Hamiltonian includes the scalar longitudinal wave due to gradient-driven currents among the crystalline layers as an explanation for high-temperature superconductivity. The electrodynamic Hamiltonian for more complete electrodynamic is written as energy of electric field plus energy of magnetic field plus charge multiplied by potential plus divergence of multiplied electric field, potential and permittivity of medium minus current multiplied by magnetostatic scalar potential plus c squared divided by permeability of the medium plus divergence of magnetostatic scalar potential divided by permeability of medium. In conclusion, we can build an antenna based on the above concept within laboratory environment and use a simulation software such as multiphysics communication solutions or analyze systems computer code to model such antenna. However, we believe that we have examined adequate analysis in this white paper to show the field of electrodynamics, classical and quantum, although considered to be totally understood, with any criticisms of incompleteness on the part of dissenters essentially taken as veritable heresy. Nevertheless it needs re-evaluation in terms of apparent unfortunate sins of omission in the failure to include an electroscalar component. Anomalies previously not completely understood may get a boost of new understanding from the operation of electroscalar energy. We have seen in the three instances examined the mechanism of generation of seismic precursor electrical signals due to the movement of the Earth's crust, ordinary peeling of adhesive tape, as well as irradiation by the special TESLAR chip, the common feature of the breaking of chemical bonds. In fact, we may ultimately find that any phenomena requiring the breaking of chemical bonds, in either inanimate or biological systems, may actually be scalar wave mediated. Thus, we may discover that the scientific disciplines of chemistry or biochemistry may be more closely related to physics than is currently thought. Accordingly, the experimental and theoretical re-evaluation of even the simplest phenomena in this regard, such as triboelectrification processes described above, is of the absolute essence for those researchers knowledgeable of the necessity for this reassessment of electromagnetics. As I said in my introduction, it may even turn out that the gradient-driven current and associated scalar longitudinal wave could be the umbrella concept under which many of the currently unexplained electrodynamic phenomena that are frequently under discussion in our conferences might find a satisfying explanation. The new scalar longitudinal wave patent itself, which is the centerpiece of this talk, is a primary example of the type of invention that probably would not have seen the light of day even 10 years ago. As I had previously mentioned, we are seeing more of this inspired breakthrough technology based on operating principles formerly viewed with rank skepticism bordering on haughty derision by mainstream science, now surfacing to provide an able challenge to the prevailing worldview by reproducible corroborating tests by independent sources. This revolution in the technological witness to the overhaul of current orthodoxy is definitely a harbinger of the rapidly approaching time where many of the encrusted and equally ill-conceived still accepted paradigms of science, thought to underpin our sentient reality, will fall by the wayside. On a grander panoramic scale, our expanding knowledge gleaned from further examining the electroscalar wave concept, as applied to areas of investigation such as cold fusion research and over-unity power sources, will explicitly shape the future of society as well as science, especially concerning our openness to phenomena that challenge our current belief systems. To the point, the incompleteness in our received understanding of the properties of electrodynamical systems can be attributed to the failure to properly incorporate what can be termed the electroscalar force in the structural edifice of electrodynamics. Unbeknownst to most specialists in the disciplines mentioned, over the last decade in technological circles of development, there has quietly but inexorably emerged bona fide physical evidence of the demonstration of the existence of scalar longitudinal wave dynamics in recent inventions and discoveries. As technology leads to new understanding, at this point we are certainly rapidly approaching a time in which these findings can no longer be pushed aside or ignored by orthodox physics, and physics must come to terms with their potential physical and philosophical impacts on our world society. By the time you read this book, this author thinks you might agree with the fact that we could be on the brink of a new era in science and technology, the likes of which this generation has never seen before. Despite what mainstream physics may claim, the study of electrodynamics is by no means a closed book. Further details are provided in the following sections of this chapter.